Good evening, everyone. Welcome for today's session. So let me share the screen now. Okay. Okay. Hi. Good evening, everyone. Once again, I welcome for today's session. And yeah, so today is the third day of our domain analytics program. So as all of us know, we have already done the previous domain analytics program in sales analytics. And oceanography analytics. Then we done e-commerce analytics. So now we are in the trade analytics program, trade analytics. So trade analytics. So in sales analytics, we discussed about some of the use cases as well as oceanography analytics. Also, we covered some of the use cases as well, e-commerce analytics. So sales and oceanography analytics, we took for 8 hours program per day, 1 hour. When come to e-commerce and trade analytics, we are having 16 hours program. We have a 16 hours program. So in a 16 hours program, every day 1.5 hour, 1 hour 30 minutes, right? So yeah, almost more than 10 days we're having classes 10 and 11 days. It's going to be 11 days. So now, very first day in trade analytics program, the very first day we talk about application of ML in trade domain. Right. So we just discussed about in which scenario we are using trade analytics, right? And second day, Friday, we discussed about crisp MLQ method. Crisp MLQ method, cross industry standard procedure for machine learning with quality assurance. So every stage, what are the different activities happen? So we look into the 6 stages, crisp MLQ. Right? Cross industry standard procedure for machine learning with quality assurance. So where we discussed about business and data understanding, right? Data pre-processing. In crisp MLQ, we discussed about business and data understanding, data pre-processing, and we look at model building. Then we have a model evaluation, deployment part, and monitoring and maintenance. Monitoring and maintenance. So there are 6 stages. Right? Okay. So now we are going to look at the second topic of data pre-processing. right? And we just discussed about descriptive analytics also. There are 4 type of descriptive analytics we discussed. What are the 4 type of descriptive analytics? We discussed about descriptive. What are the 4 data analytics? So descriptive analytics, diagnostic analytics, third predictive analytics, and 4th one is prescriptive analytics. So for our 4 stages of data analytics, so descriptive, diagnostic, predictive, and prescriptive analytics. So now we have come to the second topic of CRISPR molecule. See, any domain you are working, or any domain or any project you are working in machine learning or data science, you need to come across data pre-processing. You need to come across data pre-processing or data cleaning or data organizing. So data cleaning and EDA both are combined with each other, but it is divided as because of easy understanding, we divided into the 2 categories, EDA and data pre-processing. So what are one by one we can see. First of all, we look out for EDA. What is EDA? EDA. What is EDA? Anyone can say this? What is EDA? EDA. EDA is called as exploratory data analytics. EDA is exploratory data analysis. Okay, exploratory data analysis. Exploratory data analysis, EDA. So it is exploratory data analysis. What we are going to do? See, as usual, as per the CRISPR-MLQ, the first stage is we are trying to understand the business problem, right? We are trying to understand the business problem. So once you understand the business problem, you are trying to come up with data understanding. In data understanding, we have different kind of data types, as well as different kind of data collection, the primary data collection as well as secondary data collection. So in primary data collections, so before getting to the EDA, let me tell you about some of the important data types. There are different kind of data types we have to show you. We have a new continuous and discrete data. Continuous and discrete data. What is continuous data? The continuous data is with the decimal point. It is infinite value. Continuous data means infinite value. The decimal point will make sense. When come to discrete data, it is definite. I mean, it's a fixed set of value. The decimal point will not make any sense. That's what continuous and discrete data. Second one, qualitative versus quantitative data. Qualitative means we can measure by, we can compare. Okay, qualitative means non-numerical data. Quantitative means numerical data. Qualitative, non-numerical, quantitative, numerical data. Right? Qualitative versus quantitative. Third thing, structure and unstructured data. What is structure? Structure means the data set contain definition or schema. We used to call a schema. So structure versus unstructured data. So structure means the variable having definition. Each variable have some define or definition. It can be integer or it can be decimal point or date format or multiple things. But when come to unstructured data is audio, video and image file. Audio, video or image. So these are the data is called as structured and unstructured data. We have a big data versus non-big data. The fourth data type is big data versus non-big data. Big data versus non-big data. Right? Big data versus non-big data. Okay, fifth one. Fifth one, we have a cross-sectional time series and cross-sectional time series and panel data. Okay, so cross-sectional time series and panel data. Then we have a sixth one. Structure and structure data, cross-sectional. Then we have a batch data or live streaming data. Live streaming data or batch data. So these are the different data types we have. There are different data types we have. And the collection, when it comes to the data collections, there are two types of data collections we have. See, why do we discuss this? Because before getting the data, explore data analysis, we should know about some basic concept of some data types. We should have familiar with some data types. Most of them might be understand, or most of them may not be understand. So this is called data types. We have different data types. So data collection, we have a primary data collection, primary source data collection, and secondary data collection. Okay, the primary data collections. What is primary? We collected the data directly from the user. Directly from user. Secondary data sources. Data already collected. Data already collected, but stored in a proper structured manner. It's stored in the proper manner. Or structured manner. Maybe SQL or SAP. All sales record are called as secondary data sources. Correct? Okay. So there are some advantage and disadvantage for both primary data sources as well as secondary data sources. The primary data sources, it's necessary to the primary data sources for necessary to, it is time consuming, right? And expensive, more expensive. Time consuming and expensive. The good thing is we can collect whatever we want for analysis. That one thing from the advantage and disadvantage of primary data collection. When come to secondary data collections, we have some good advantage and disadvantage. Advantage and disadvantages. So secondary data collection, easy accessible. It is easy accessible. Easy accessible. Second thing is, it is not favor of our interest. It is not what we expected. Because the data collected as per their requirement, the client requirement or the company requirement. Right? So we cannot take we cannot take the data, whatever we want. See, once you finalized your business understanding, you need to have a conversation with your client. What data they have, what is the time period data they have, how to access the data. Right? So multiple things we can learn from different perspective. Okay, when come to EDA, the VDA is exploratory data analysis. So it is the initial part of time, it's the initial investigations we are just doing on data to discover some pattern. Pattern means how the trend or what is the mean median move, right? So that thing we are going to continue that. So before continue that, we know, right? We know what are the different kind of data we all know, right? So based on the data, we are going to choose the algorithms. So the quality of data is of the huge contribution, right? So your quality of data will determine the success of your model building. So success of your data. Okay. So now we look at the 4 type of EDA process. 4 type of EDA. Before that, we have an analysis. We are doing analysis. So once you collect the data and once you understand the data types, next you need to look at what kind of analysis you're going to perform. What are the analysis we have? We have univariate analysis. We have a bivariate analysis. Then multivariate analysis. Okay, univariate, bivariate, and multivariate. What is univariate analysis? Univariate analysis means you're taking one variable. For example, age column. So when you are having data set, the data set contain multiple variables. But you take one variable and you performing all statistical and mathematical methods. Statistical and mathematical method. Age, gender, right? So you do one column, one variable, and you're performing all mathematical method. So this is called univariate analysis. Univariate analysis. What about bivariate analysis? Univariate analysis, not only mathematical foundation, also we can use visual diagram. What is the best example of visual diagram? You would say bar plot. And we have a histogram, right? Bar plot, histogram, box plot. Okay. So bar plot, histogram, these are all called as bivariate analysis. So sorry, univariate analysis. You are taking only one column at a time. Even though you have a multiple column in your data set, you can perform one column. Take one column and just perform all the mathematical calculation. When come to bivariate analysis, take two columns. Take any of the two columns, age and salary. So you're trying to hit a relationship. You're trying to have a relationship. We are trying to find the relationship, I would say. So bivariate analysis, we can say correlation analysis. Correlation. Correlation means a relationship. So we try to understand the relationship between the two variables. We used to call as R value or small r. That's called regression. To maintain the relationship. To relationship. Got a case? But visually we can take. Visually, how do you do that? Visual diagram. Visual diagram means you're going with scatter plot. They're going to look at the scatter plot. Scatter plot, we can identify, for example, you have X and Y. In X and Y, there is a relationship. You're going to find the relationship. For example, age, I would say it is experience and income. So if X is increasing, that means the experience is increasing. What impact happening on the y-axis? X is increasing, Y is also increasing or decreasing, anything, any impact. So any impact on Y, if X is increasing, if they make any impact on Y, then that's called, that is a relationship. Then there should be a relationship. right? So that is called scatter plot. That means the relationship should be there. But three things we have to look when you're talking about bivariate analysis. We can look at three things. One is called linear or consistency. Second, direction. Third, strength of the data. Third, strength. Right? So we have a linear or consistency, or direction, or strength. So linear consistency means when X value is increasing, what about your Y value? It keep increasing or not? So direction could be a minus or negative. What is positive direction? When your X value is increasing, if Y value is also increasing, then that's called positive relationship. Positive relationship. When X value is increasing, Y value is decreasing. That's called negative relationship. Negative relationship. So positive relationship as well as negative relationship. Right? Positive relation, negative relationship. The third thing we are talking about, strength. Strength means strong, moderate, and weak. Strong correlation. What is strong correlation? So we have a R value, right? If R value is above 0.85, it's a strong. The value anything between 0 to 0.5, 0.4 to 0.85 is called as moderate. So below 0.4 is called as weak. Right? So positive relationship and negative relationship. So here we have strong, moderate, and weak. If at all anything the value below 0.4, then R value, then there is no relationship. Right? So that's about the bivariate analysis. When come to multivariate analysis, so multivariate analysis in the sense at the same time, all variables play a vital role. So all variables play a vital role. It helps to increasing the output. It create impact on the output. All input has create impact on output. That's called multilinear regression. Multilinear regression technique. So all the input will make impact on output. Impact on output. So that is what called multilinear regression. So simple linear regression as well as multilinear regression. So multilinear regression, we have a multiple variable which will impact the output. Which will impact the output of the data. Okay, so once we completed now analysis, then we can come to the topic of EDA. As I mentioned, it's the initial investigation about your data. It's the initial investigation about your data, EDA, exploratory data analysis. So EDA, there are 4 stages. One is first moment business decision. Second moment business decision. Second moment business decision. And we have a third moment business decision. And we have fourth moment business decision. So what is happening in the first moment business decision? The first moment business decision, we are going to capture this measures of central tendency. Measure of central tendency. Measure of central tendency is what, guys? What does it mean? Measure of central tendency. So measure of central tendency, we have a mean, median, and mode. Mean, median, and mode. Mean, median, and mode. So mean means the measure of central tendency. It's a measure of central tendency. Okay, mean. Mean means average. When you calculate mean, average. So if you take age column, there are 30, 35, 20, 25, right? So let's assume that there are multiple columns we have. Let's take age. So age we have a 25, 35, 40, 25, 30, 35, etc. If someone is asking you, what is the age group of people in your company? Or let us say any institute where you worked, where you conducted. So what is the average age student of the people who are attended in your institute? So what did you say? Can we say like 25, 35? Will you say all the value? No, right? So we have a single value of representation. We have a single value of representation. So if you want to represent the complete value for multiple row, you can represent by the single number. That single number is called average. It is called mean. Mean or average. So what happened here mean is that it will show, it will represent the characteristic of data. It will show the characteristic of data. Right? So the single value will represent the characteristic of my entire value. So that is called average or mean. Okay, so in the school days, we may be studied about mean, but with respect to data science, we have a average. Sorry, school days, we might be studied average. So now with respect to the respect to data science, we used to call as mean. Okay, but there is a some disadvantage about mean. What is the disadvantage of the mean? The mean is which is influenced by, okay, before getting into that, just a minute, my bad. Okay, sorry, my bad. So what is that? Where I was? Okay. So mean, median. So in case, let's assume that the income of person, the income for 10,000, 14,000, 17,000, 12,000, 13,000, and 14,000. So when you have a data set like this for specific column, okay. So what if the specific new column, new value is called as, will it change complete characteristic of data, isn't it? See, one single value, the if you calculate average, it will be more. If you open that, just let me open this. Yeah, let me open the new data set. Number age, or let us see income of people. So 10,000, 15,000, 12,000, 14,000, 13,000, 14,000, and 30,500. Let's assume this. So what is the average of it? The average is 13,001. 13,007. Let's assume this. This is your average mean. But when that is the other B school, let's take this is one of the B school A. B school A. Let's take B school B. Okay, their income is same as it is. But let's look at that. We have a, what is the average now? Yeah. Can you do average over here? Yeah. So now let us look at that. 1,54,000. My bad. See, because of one value, what happened here? The same value, but except that one value, right? That one extreme value will make change the characteristic of data. That's what we want to look into that. The single value will make changes or will make impact. The single value will change the characteristic of data, will change the characteristic of data. So that is called outlier, the extreme value or abnormal value. We can say extreme or abnormal value. This is called outlier. The extreme or abnormal value is called as outlier. The outlier characteristic is the outlier will influence the outlier. It will change the characteristic. So we need to remove. So that one thing. And apart from that, how do we handle that? We can handle by the second value called median. The second thing is called median. So median, when you sort out the value, when you sort out, expand the sort, then we have to get the middle value of that. What is the middle value? How many values are 1, 2, 3, 4, 5, 6, 7? So middle value is 14,000. Right? What is the middle value here? 1, 2, 3, 14,000. So this is called $14,000. Okay. So this is called median value. The median will not influence the outlier. So medians will not get influenced by outlier. So when your data set is contain when your data set contain outlier in your mean, then you have to select median. You look for the median value. So that's called median. Next, we have a mode. What is mode over here? What do you understand mode of that? So mode means when you have a non-numerical. For example, there is a designation or educational status, BSc, BSc, okay, and MSc, B. And so on. So a BSc, how many times the BSc value having? So BSc I have 5. So whichever most repeated value or most frequent value is called as mode. So mode is nothing but the most frequent value. That's called mode. So now we understood the first moment business decision. Right. So the first moment business decision is talk about measure of central tendency. Measures of central tendency. So mean, median, and mode. Central data. You're understanding the characteristic of the data. Second thing, measures of spread or distribution. Measures of spread, distribution, or dispersion. Okay, that is about second moment business decision. It will talk about spread, dispersion, or distribution. What about that? Because when you are calculating average, see any business you do, if you are start any business, one of your relative or well-wisher to come to meet you, what is the first question they will ask you? Can anyone say what is the first question they will ask you? The first question they will ask you about what is the average sales or what is the average salary or what is the average income of your business. So that is what everybody's looking to that. Right? Okay. So second moment business, the first moment business decisions alone will not to help you to get more insight in our business. Okay, guys, do you understand? So we need to look second moment business decisions. We need to jump into the second moment business decisions. So what are we doing in the second moment business decision? When you look at that, so when you look into the second moment business decision, we have three variants. One is called variance, standard deviation. Third is range. So variance, standard deviation, and range. What is variance, first of all? The variance in the sense how it is used to measure the average spread in the data. Used to measure average spread in the data. Right? So average spread in the sense when you talk about average spread, how the value away from the mean, how the values are away from the mean. See, when you're calculating for age and different factors, for example, when we have we looked into the age column 20, 25, 30, 35, 34, 40. In this. Okay, what is the average of that? 28. So how the average spread is away from the each value? How the mean is away from each value? That's what we have x minus mu. X minus mu. For example, we have x minus mu. X minus mu in the sense x minus mu. The value which we have x, it is called as minus divided by the average. So when you make it, yeah, you get the result. That means x minus mu, it should be average, should be the 0. Think of. Okay, so but we made wrong here. Let me. So what is the average of it? Average is 0. So in order to avoid 0, so in case if you are subtract your average with the x value, when you calculate average, it should be the 0. That is the fact. To avoid this, what we need to do, we need to make a square of it. So x minus mu of whole square. So I'll make like this. So when you do 64, got it now? So what is the now? This total summation of it? 322. What need to be, we need to take average of it. Average is 46. How do you find the square root of it? 46. So square root of SQ or T, square root of 46. Let's take 46. So 6.7. The average spread is 6.7. The data point which is from the data set. With the 6 value away from, that's called standard deviation. The 46 for variance, standard deviation is 6.7. 6.7. So this is called standard deviation. So variance means x minus mu r. The variance may be, or the variance is sigma for population. Sample, you have a s square. So sigma square equal to summation of x minus mu whole square divided by n. Here n minus 1 sigma. So that is about second moment variance and standard deviation. The other thing what we have is a range. What is that range? The range is maximum minus minimum value. Max minus minimum. That's called range. The range is called max minus minimum. So range, max minus minimum, and you have a standard deviation also. So this is about second moment business decision. Okay, when it comes to third moment business decision, we have a third moment business decision. So third moment business decisions, we have skewness. Skewness of data. What is skewness? Skewness of data. Skewness is measure of, it used to measure this asymmetry. It's a measure of asymmetry. It's used to measure asymmetry. Okay, so here we are going to look at which side the more distribution. Which side is more distribution? It can be a left side or it could be a right side. Okay, whether if more data in right side of the data, that means if you look at here, this is called right skew. When your data is like this is called left skew. So right skew, left skew. So when come to left skew, that means more data or concentration on the right side. More data concentration on the right side. Just in front of. Okay, so skewness, asymmetry. So how do we do that? How do we measure or how do we come to interpretations for left skew and right skew? So left skew in sense mode is bigger than median and mean. This is called left skew or negative skew. When mean, median, and mode are called as normal distribution. Median, let's take mode. Mean is bigger than median and mode. Sorry, my bad. Sorry, guys, there is some disturbance interpretations. Okay, fine. Okay, now so we have a mean, median, and mode. Mean, median, and mode. So when come to left skew, we are going to we discussed left skew means mode is higher value, right? Or when left skew means yeah, the mode is higher value than mean, median, and mean. But when come to right skew, mean is higher than median and mode. So that is about skewness of data. So when we do this mean, median, and mode, how do we reference it, or how do we interpret by the formula? When you're using formula, how do we interpret by using formula? The formula can be used by x minus mu of divided by standard deviation, the whole square q. See, what we used to do, we have a first moment business decision, right? So what is the formula for first moment? Mu equal to sigma xi divided by n. So what you do in the second moment business decision, we are using the first moment decision into the second moment business decision. So x minus mu of and whole square. So what do we do here? We used to do second moment business decision and we used first moment business decision so far. Right? And third moment business decision. So x minus mu divided by n minus 1 whole cube. The whole bracket cube. Okay, so x minus mu divided by n minus 1 whole cube. So this will talk about the third moment of business decision. Third moment of business decision. So first moment business decisions we understood. Second moment business decisions we have tried to come to know that, and we'll learn third moment business decision also. When come to fourth moment business decision. So if you look at fourth moment business decision, we are going to measure the cortices. We are going to measure the cortices or cortic. We are measure the cortic. What is cortices or cortic? Cortic means weakness. Weakness of data. Weakness of data. Weakness of data. So when we talk about the first moment, we said we are measuring the central tendency. Second moment, we are measuring the dispersion. Third moment, we're measuring the skewness or symmetrical or asymmetrical. You can say asymmetrical. Right. So when come to the fourth moment business decisions, we talk about cortic or cortices. We're going to talk about cortices. So in cortices, in cortic, we are going to measure the weakness of data. When your data is mean, so we are going to measure the weakness of data. So when your data is normal, we cannot have a normal distribution. This is also called as normal distribution. It is a usual data. So let me show you that the slide. Okay, so when you come to here, we have a what we discussed? We discussed about the mean. Sorry, kurtosis. So when you talk about kurtosis, your data is wide peaker, or your data is short. This is short peaker, short peaker. The another is wide peaker. This is normal. Wide means, let me show you. See, all three data is normal distribution only. There is no doubt in it. All data is normal distribution alone. But how to vary? The varying from the top of the peak. That's why we used to call measuring the peak. We are measuring the peak. So top peak. If it is wider, if it's shorter peak, that means more data close to the mean. Majority of data close to the mean. But here data is widespread, widespread. 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 So that is called widespread. Called used to call as negative kurtosis. So this is positive kurtosis or positive kurtic. See, we have a different name, guys. We can call us in different name. For example, in order to this, let me my bad. Sorry. So in kurtosis, let's take this. So when you have wider, this wider peak, we have this is called platy cutting. Sorry, sorry. So this is called a platy cutting. When you have a sharper peak, that is called leptocurtic. When you have normal, that is called mesocurtic. So platycurtic, leptocurtic, and mesocurtic. So there are different variation in the kurtosis. Right? There are different variation in the kurtosis. Okay. So what do you understand from this? See, before if you just knowing if you are knowing that skewness data, you must understand the normal distribution of the property. Because there are 5 important properties for normal distribution. What are the 5 properties to normal so that we can connect with skewness and kurtosis? So I should have talked first these things. Okay, anyway, that's not the matter. I'll talk about here. The first thing is we're talking about here is the value fall in the range from minus infinity to plus infinite. The value will fall in the range of minus infinity to plus infinite. The probability of single value always will be 0. The probability of single value should be 0. The area under curve always should be equal to 1. Okay, the area of under curve always equal to 1. And the curve will always follow in the symmetrical nature or bell-shaped curve. It is a bell-shaped curve. So it used to follow bell-shaped curve. Fifth thing. So fourth thing is we used to call as mean equal to median equal to mode. So these are the 5 properties filled for, or it is majorly covered. Right? So the value can be fall in the range of minus infinity to plus infinite value. Probability of single value equal to 0. The area under curve equal to 1 and symmetrical. So symmetrical means bell-shaped curve. So why do we do that? Why do we say the probability of single value is equal to 0? Because if you have a discrete data, there is a fixed set of value. See, before that, I would confirm that everything before the assumption is it should be continuous in data. The normal distribution looks for when the data is continuous, then we can perform on. Then we can perform on this distribution. So probability is okay. When you come here, see when your data is discrete data, there is a fixed set of value. So the value has been fixed. But when come to single value, probability of single value, when area under curve, that means area under curve. That means we are doing calculation for every value. Since it is continuous data, we have to calculate all the value of it. So that is called area under curve. Area under curve equal to 1. And we say mean, medium, mode. So the values mean, medium, mode are other equal. So that one thing we have about that. So this is what about the EDA process. Okay, but still we have not started our data pre-processing. Still it is pending. Yeah, since due to the time constraint, because we spend more time on to understand the data type and expert data analysis. So I think tomorrow we will have a discussion about data pre-processing and complete. So we more discuss about in this class we more discuss about EDA data types and EDA mode. Okay, fine. So let's quickly, what is the importance of data pre-processing first of all? What is the importance of data pre-processing? See, the data has been collected from different sources, right? We used to say primary data source as well as secondary data sources, right? Primary as well as secondary data sources. So primary data sources and secondary data sources. So primary data sources means you're collecting the data directly from the user. Secondary means already data collected somewhere else. So when you're taking primary data sources, there are more chances. There are more chances the data will be collected in different aspects, different format especially. The data may be collected from different formats. Data may be collected from different formats. So this will not be acceptable format. Maybe the data types or data format may not be acceptable by the algorithm, which algorithm we are using, the machine learning algorithms. It may not. Right? So the first enemy of data is raw data. See, in your data science, your first enemy is raw data. First enemy is raw data. So in raw data, the data may have missing values, right? Or the data having a duplicate values, or some have different outliers, right? Or maybe having different data type, for example, numeric or non-numeric. Because when your data, which data we most preferred this? Which data we used to most prefer? We are most preferred on numerical data, right? Numerical data. In case if your data is non-numerical, then what you do? We need to convert into the numerical data. Because when we discussed about in the quantitative to quantitative, we remember, right? We discussed about it. So qualitative data and quantitative data. So when your data is qualitative, that means it is comparable. It's not a measurable, it is comparable. We cannot measure the unit. Quantitative data, yes, we can measure by unit. So we discussed that one. So the most preferred data. So what we need to do when you are converting non-numerical to numerical, when your data is non-numerical, then we can use some data pre-processing technique. That's called dummy variable creation. In dummy variable creations, we have one-hot encoding or label encoding. So we will see in tomorrow once again. So now I'm just quickly introduction about this side. So again, we will have quickly, we can recap all these things, whatever we discussed. So in detail, we will see tomorrow. Don't think about it. Okay. So data types. So data may be captured some cache or some thing called logs. So the data preparation contain data cleaning, the two categories. In data preparation, what we do, we have to do data organizing and data cleaning. Data organizing and data cleaning. That's also we used to be covered. So yeah, data pre-processing, we are having to do two data pre-processing. Because in textual data and intersectional data means how do we perform? For example, your data is in Excel format or CSV format. So when your data is numerical form, in the cross-section format, table format, you have a different data pre-processing. But at the same time, when your data is textual data, it's like a kind of paragraph of documentations. So that's what we use to NLP concept. In the NLP concept, you have some data pre-processing. That's called textual pre-processing. Textual also data, so sexual data pre-processing. Textual data pre-processing. So the pre-processing can be done for two different things. One is called, it's a tabular format. In tabular format, you can do you can do that typecasting method. So typecasting method is nothing but you are converting one data type into another data type. We will look tomorrow. One data type another data type. That's called typecasting. The second is we have look at this handling duplicate. What is handling duplicate? When you have a data, intersectional data, when you have a tabular data, it can be rows and columns. It will be rows and columns. So when you have a row and column, the row may contain same information. The row contains same. For example, the row age, for the customer detail, age, gender, transaction amount. So that means when the row number 1 and 15 or 18 are same, okay, when age, gender are same, that means this is redundant information. That is called redundant information, the repeated information. We use call as repeated information. So it is not required because the computation will be increasing. If you do that duplicated row, your computation will get more. The computation will keep increasing. Okay, computation will keep increasing. So to avoid this, we can reduce it because it's going to help you, right? Because the same information every time you are going to get, right? You are going to get the same information. So you're going to get the same information. So we need to avoid duplicate by using drop underscore duplicates. So like that, we have a different various things. And when come to textual data pre-processing, when it comes for textual data pre-processing, we used to have when you have textual data pre-processing, you can have vectorization, lemmatization, or stemming. Right, lemmatization, stemming, vectorization, lemmatization, stemming, and stop words removal. There are various things we can perform towards this. Yeah, of course. So these are things is anyway, it's going to help you a lot. Okay. So we will see this tomorrow, guys. So we are in tomorrow's session. So due to, I think today we take over time for all these things. For example, remove HTML tag, remove extra white spaces. convert Accenture. Okay. So removal of white spaces coming out. So all these things we will see it tomorrow. Okay. Yeah. So yes, with this we are stopping today. On tomorrow.